Hi, welcome to my channel Process Simulation. This is the continuation video with our previous lecture about Pipesim. In this lecture, we will learn that how we can change the environmental condition for each line. Moreover, we will see that how we can get the densities, how can we get the flowing density and the actual densities from the Pipesim, and how can we develop the things, how can we see that the flow patterns are different and all those things. For that purpose, let's go start. So we will start from the network system, new network. So let's create a scenario in which you have a pipeline somewhere around 3 to 4 kilometers that is underground, and after that it enters into a station where it is above ground. So as I stated earlier, so we will see how can we model the both thing, because at the same time your underground temperature ambient and ambient temperature of the above ground line cannot be same. Let's move forward. First, we will do the regular things, and that is we go to a fluid manager and we will decide our fluid. So since we are not using any composition, we will try to go with the black oil or simple gas thing rather than going into the uh, compositional side. Here I have selected a dry gas. So once you select a dry gas, you mostly the things are that it's complete the gases don't have any liquid things. So mostly the specific gravity is 0.66, which means that we are considering a relatively methane plus system. Let's move forward. So since the most important thing is the fluid characterization that we have done by adding a black oil, or we can go for the compositional things. So first we go and we will add a source and we will add sink, and then we will have a one junction point. This junction point will represent the above ground and underground pipe. So we will assign a fluid that we have already done. We will give the temperature. So for right now we will give the gas, we consider a summer scenario, we consider the gas is flowing at 50 degrees C temperature. And for the gas flow rate, we will say that let's have a 15 mmHg of the gas. Just take a scenario that we have to meet a landing pressure of 20 bar, 20 bar gauge. Sorry, I put the PSI 20 bar gauge. So as I earlier said that let's first we go with some kind of a 6-inch line. We will see that how 6-inch line will see. And if the pressure drops are very high, we will go for a higher size line. Some 3 kilometer and 15 at relation will work us. Here we will consider the same 6-inch line. Let's assume the here the line is not going more than 450 meters. So if you see our everything we have modeled, now we will go to simulation settings. So when we go to simulation setting and environment tag, we will come to know that we have put a temperature by default is 60, that is 15.3. So considering the summer scenario, I know it is mostly 50. So I will put the 50 here for the overall. But I know uh, inside the soil, the temperature is not same. Then we will go and change it. So for this line, everything will remain same. We know that is more simple, and this line is on the land, and this line is where in the air will be the better value. Okay, when we go there, we have to model this line should be underground line. So for underground line, we have to go to the detail model. Detail module, you have to put a complete elevation profile that it will come automatically based on that. So here we will see that this line is the detail line. Five things are there. Heat transfer mode, calculate. On the calculate, I will show that my pipeline is mostly 1 meter or 0.8 meter depth. So I will put 0.8 meter. So this so that my whole ground is underground. So here there is one option that is called override global data. So for global data we have already put 50 degrees C. So if we override, once we override this data, so if you see on the heat transfer mode, I got a one more thing, that is what's the ambient temperature. So now I will say that my ambient temperature is not 50 degrees C for this pipeline. For this pipeline, we will consider 35 degrees C as underground temperature. Let's run the model and see the results. So as you see, the difference that come in the sink is not greatest of the temperature. We will go on the profile tab to see that how the temperature change over the whole profile. So if you see here, once the pipeline starts, it's having a 50 degree C, and over the course of 3 kilometers, because of the ambient is 35, my temperature dropped to 44. But on when the pipeline come above ground, and here at that point the ambient is same 50, your temperature start getting near 50 and it's end at 49. So but at this module, what we try to learn here is that how we can have the different environmental conditions for each line. In simulation setting, we can go and put the one temperature and one conditions, but we can go to each line and override the things to get the required points.